Hello? Hello everyone. Let's continue to look at a topic on HCI storage. Next, we will specifically look at the working principle of mechanical hard drives. So first, we just briefly mentioned it earlier specifically. You can take a look at this picture. This is a basic operational method. First, our hard drive here, each disk has what? It has two read write heads. They are used for reading and writing data on the two surfaces of the disk. The read-write head, it uses airflow to float above the disk surface. It doesn't actually make full contact with the disk surface. If it were to make contact, since this is entirely a mechanical operation, if it touches the disk, it would definitely cause what? It would lead to the disk surface would experience some wear. And if it makes contact, it's actually not conducive to what? It's not conducive to high-speed movement. So, by not making contact, firstly, we can move back and forth at high speed between the tracks without touching the disk. Of course, if the read-write head is too far from the disk surface, the signal will be too weak. If it's too close, it might wear down the surface of the disk. So firstly, the disk surface must be very smooth and intact, and there must not be any foreign objects or dust present. If there are any, it might cause the read-write head to rub against the disk surface, leading to permanent data damage. Since this is a purely mechanical structure, if any part of the mechanism is damaged, the entire disk will be affected, ultimately impacting our actual data. So everyone must pay attention to this. Here first, regarding the working principle, the first step is that our read-write head is located here. Our read-write head will dock in a special area on the spindle attachment of the disk, which we generally call the landing zone. The spindle here connects all the disks, and then it is ultimately connected to a motor, and the spindle motor will rotate at a constant speed, driving all our disks to rotate. When the spindle rotates, what is there between our read-write head and the disk surface? There will be a tiny space, an air gap, which is generally called the flying height of the head. This absolutely cannot be in contact, right? Vibration might lead to what? It might cause some friction between our head and the disk, so this is why it cannot be subjected to vibration. The read-write head is generally mounted at the top end of our head arm, right at the top. It will drive our head to move. Move to the position above the disk where data needs to be written or retrieved. Here, there is both reading and writing. You should note that both reading and writing rely on this head. It's all dependent on the head. The head? On the surface of our hard drive, it reads data in binary form. After reading the data, where is it stored? It is stored in a flash chip on our hard drive, which is our cache chip. Finally, it is transferred into the program. This is the overall working principle of our mechanical hard drive. As mentioned earlier, each head and each platter must not touch each other. This is mainly because, as mentioned earlier, they cannot rub against each other. And the reason they cannot vibrate is that vibration can inevitably cause vertical movement, which might lead to what? It might lead to our friction between our read-write head and the disk surface, and once there is friction, it can lead to data damage. Some data damage. Moreover, if the friction is quite severe, you might end up with this part. That is, this small section of the disk platter could be completely damaged, completely ruined, and it won't be usable in the future. It won't be usable anymore. Subsequent changes would require what? They would require separate repairs for this part of the content. This is the overall working principle of a mechanical hard drive. Now here, let's look at what? Let's look at a test diagram. Here, we actually have what is called a top view, meaning we are looking from above. Next, let's look at another test diagram. We can see here, as we mentioned earlier, we originally have multiple platters. Originally, there are multiple platters, and they actually look like this. We place multiple platters simultaneously in our central spindle we just mentioned, name. Then the spindle drives the entire system to move, driving the whole system to move. Here, this is our entire disk. It's like splitting the disk to show everyone the effect. So first here, regarding our disk section, there are a few concepts to explain to everyone. First, there's the disk surface. Each hard disk platter, as we just introduced, is a platter. A single platter has two sides, top and bottom, and both sides can store data. They are both capable of storing data. Then, each active surface will have a surface number, which is numbered starting from 0 in ascending order. In the disk system, this is generally referred to as the cylinder number, meaning each active disk surface corresponds to a disk cylinder number. For example, from top to bottom, it would be 0, 1, 2, 3, 4, 5, 6, 7. 0 to 7 actually represents a total of 4 disks, with 8 surfaces in total. At this point, our basic definition of a surface is that each surface can store data. It's not just single-sided, it's a double-sided storage. Next, let's take a look at the second point. Now, on our disk surface, this circle here, what is it called? This is called a track. A track is a concentric ring on the disk surrounding the spindle, where our data is recorded. The tracks are numbered, starting from 0, from the outermost ring to the innermost ring. On each surface of the hard disk, there are generally between 300 and 1024 tracks. This varies with different models of hard disks. Newer high-capacity hard disks will have more tracks. Here we usually use the number of tracks per inch on the disk to measure the density of the track arrangement on the disk. We cannot see these tracks with our naked eyes. We cannot see them with our naked eyes. They are just some tracks on the disk that are magnetized in a special form. These magnetized areas are not visible to the naked eye. Please take note of this. In the diagram, we have drawn the tracks, but in reality, we cannot see them. Next, besides the tracks, what else do we have here? We have cylinders. Horizontally, this circle is the track, and vertically, it is the cylinder. A cylinder in the context of the same hard disk includes all the platters, both the upper and lower surfaces of all the platters. Tracks with the same number form a cylinder, and this cylinder is what we refer to as a cylinder of the hard disk. The heads on each cylinder are numbered from top to bottom, starting from 0 to 1 to 2, and so on. For data reading and writing, it operates according to our desktop, meaning that when the read-out-write head accesses data, it starts from the 0 head on the same cylinder and proceeds sequentially downward. Only after all the heads on the same cylinder have completed reading and writing will it move to another cylinder. Therefore, selecting the head only requires the electronic selector here, while selecting the cylinder must be done through mechanical switching. That is, it needs to seek. Typically, the position of the read-write head in a hard drive is indicated by the desktop number, not by the track number. So, please take note of this. Here, there's one last concept, which is the sector. The sector is located at this position. The sector is located at this position, and each track is divided into smaller units, which we generally call sectors. The main purpose of dividing into sectors is to make data storage more organized. A sector is the smallest storage unit in a hard drive that can be individually addressed and located. The number of sectors per track can vary between different hard drives. However, typically, one sector can store 512 bytes of user data. There are also some hard drives that can be formatted into larger sectors, for example, sectors of up to 4 KB. The size here can be adjusted based on the formatting. Content can be set differently. This is the overall structure of our data, or disk structure. In other words, the organization of data on the entire hard drive includes these elements, such as the disk surface, track, cylinder, and sector. These are the basic concepts that everyone needs to understand. Well, this is the working principle and overall structure of our mechanical hard drive. Alright, if anyone wants to learn Washington technology or obtain the Washington question bank, please send me a private message or leave a comment below the video for technical exchange. Well, today we will first